In this project, the piston that we chose are Toyota 22R TE to be analyzed. The piston was drawn into 3-dimension shape in SolidWorks software and analyzed using Nastran in CAD software. So about the literature review, as I mentioned, we choose a Toyota 22 RTE as our model. So the engine, so the layout of the engine, it has 4-stroke, inline 4, straight 4. The fuel type is gasoline, use petrol. The displacement is 24 liter, about 366 cc. So the fuel system is electronic fuel injection. The power adder is use turbocharge. The power output is 137 PS at 4,800 RPM. So about the cylinder block, it use alloy cast iron, and the compression ratio is 7.5/1, and the cylinder bore is 92 millimeter, and the last one, piston stroke is 89 millimeter. So that's all for me. Thank you.
Hello everyone and good day, especially to our lecturer, Associated Professor Dr. Devarajan. So today in this video, we are from Group 2 from Engine Design Section 1 are going to present on our project named Piston Design and its Calculation. So before we go through our slide, I would like to introduce myself and my group member name. So my name is Muhammad Ashraf bin Abdul Wahab, MH17016. My group member name is Muhammad Zulhilmi bin Muhammad Zainuddin and Muhammad Afiq bin Ahmad. Basically, our member only left 3 group member because one of our group member cannot continue his study in this sem. So in this slide, I'm going to present on abstract and acknowledgement. So in this study, we are about to study on the designing and analyzing of an IC engine piston of Toyota Hilux 1988 2.4 liter. So piston is the part of engine which converts heat and pressure liberated by fuel combustion into mechanical works. Engine piston is the most complex component among the automotive. Various thermal and mechanical stress can be the factor of its failure. The working condition of piston is more difficult than other part of the internal combustion engine. So, the main objective of this project is to investigate and analyze the stress-strain distribution of piston by using SolidWorks. This report required for evaluation for the cost engine design. The designing of the piston is the based on the procedure and specification given in data handbooks. The dimension for the calculation is calculated in terms of SI units. This project also determined the pressure applied on the piston head, temperature of various areas of piston, heat flow, stresses, strain, length, diameter of piston, and hole thickness, parameters, and etc. So, we wholeheartedly express our sincere gratitude to Associated Professor Dr. Devarajan, who lots of guiding us for the completion of this project about the engine piston. We also would like to express our gratitude to everyone who has supported us directly and indirectly, gave us the possibility to successfully to complete our project. Then, we thank all of our members itself that helped in the fulfillment of this project. Last but not least, we would like to thank our parents for their support and encouragement throughout the study. Without their support, we could not have undergone this project smooth and successfully. So, the next part will continue by my group member. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. So today I want to present the discussion and result. And my name is Muhammad Jeremy bin Muhammad Zainuddin from Group 2. So this is the deformation of piston. So I use the Autodesk Nastran Inventor. Next is strain result, and this is the stress for a piston. So this is aluminium properties in Nastran Inventor. So the value of aluminium properties generated from Nastran Inventor. This aluminium has 2.7 uh, power of 10 negative 9 kg per mm cubic of density and uh, 68,900 MPa of elastic modulus. So that is the result from Nastran Inventor. So you can see maximum stress, maximum strain, and maximum displacement. Okay, this for maximum gas load on the piston, uh, we use the formula force equal to P and time by MT. So we got the value 64,756.9422 Newton. From the analysis, the maximum stress achieved from the aluminium, which is 66.796 Pascal. If we divide the area, we can get 1.58 times 10 power 10 Newton. These are the amount of the force that the piston will start to deform its shape. If the piston receives load below than this range, it might withstand the load and do not create any deformation at the piston surface. The maximum stress obtained from aluminium, which is 2.9 power of 10 negative 3 meter. The maximum displacement achieved is 9.09 times 10 power of negative 5 meter. The maximum displacement so is equal to amount the deformation received from the amount of maximum gas load that we put, which 64,756.9422 Newton. From this data result analysis, we can conclude that aluminum is lower cost material that can be used for manufactured piston because it is strong enough to withstand the force given to. So that's all.